Thank you very much.
Right. So let me just give 2 words. Ricardo is a research assistant at the Center for Intelligent Sensing at QMUL University of London. And he's working on the CORSMAL project right now. So this presentation is going to be about the CORSMAL benchmark for human-robot handover.
Thank you, Ricardo. Thank you for the presentation, and thank you, Alessio, for your introduction on the datasets on CORSMAL. So in this last talk, and thank you all the attendees for staying with us, we will be discussing and we will be presenting the CORSMAL benchmark. So this is an application where we can use, and we use the data that we have been presenting in the prior presentations. And specifically, we are interested on the dynamic handover problem, where a human is handing over an unknown object, an object that has not been seen on the training data, and we want to do the handover towards a robot. So here we have an example where we are showing this. So the handover task starts with a human grasping of an object, in this case a container or a cup. There is a period where the human is manipulating the object that we call human manipulation until there is a contact with the robot. In this moment is where the human to robot handover happens. We have a third period of human or robot manipulation where the robot is moving the container towards a safe position that can be, for example, back to a tabletop where the robot is doing the delivery of the object. So here we are envisioning this task, and we are proposing a benchmark that is affordable in terms of resources and that can evaluate the performance and compare the performance in a fair manner of real-time evaluation of dynamic handovers. And the benchmark also doesn't require motion capture systems. It doesn't require markers on the objects that might change the behavior of the human or of the evaluation. And also it doesn't require any prior knowledge of the objects. So next, I will show you a few examples of how a baseline that we are making open source and is already available for the researchers is performing. We can see different containers that they are also filled by different feelings, making the problem more challenging. Also, the containers have different shape, like for example, this wine glass. And also they have different deformability and materials, like for example, this small white plastic cup. So this task is challenging mainly for 2 reasons. So the first one is related with the unseen of the object. So we mentioned that the algorithm that is underlying here, the perception algorithm, requires to perform in real time for estimating these physical properties of an object. So by physical properties, we mean we require to estimate the location and also the dimensions on this object that has not been seen in training. And the second part of the main challenges is related with the variability in the grasping type and handover location. So these are the variability that the human is introducing in this task. Now I'm going to show you the setup that the benchmark requires for performing the comparison. We need first a tabletop. In one side of the tabletop will be the human or the subject that is going to perform the handover, and in the other side is the robot. The task of the handover starts with the container fixed in a predefined initial location. The human will grasp the object and will perform the handover in 3 different handover locations that we will later evaluate differently. And regarding the affordable setup that we mentioned at the beginning, we only require a minimum of up to 2 cameras that we propose to be located in those third view positions. And also we allow to use other type of sensors, like for example, optionally, you could use force sensor or tactile sensor, as we already saw in previous presentations in this session, that might be useful for this task. And we believe we would like to explore also that direction, so we allowed the use of these additional sensors. Regarding the objects, we propose to have 4 containers. So we chose containers like cups and glasses for different reasons, because they have challenges for both sides, the vision side and also the robotics part. For example, these containers have different deformability. the one, for example, on the left is highly deformable and the one on the right is rigid. It's not deformable. Also because of the transparency, like there are different levels of transparency that makes the vision and perception more challenging from that perspective. And also this makes the robotic more challenging depending the deformability, because this will influence on how the whole system should behave. And following up with the presentation and the discussion that we had in the prior panel, we have the partition links, and also you can request us the objects and we can deliver them to you for doing your own experiments. So this way we want to have a longer span where the benchmark will be available and useful for the research. We also introduce here different grasp types. So we say to the human to grasp the object in 3 different manners of increasing difficulty. So here the difficulty, the grasps are first on the first row by the bottom. So the grasping will be done on the bottom of the container where the occlusions introduced by the vision system are minimal. And for example, in the last row where we have a natural grasping that the human is just asked to grasp and hand over the container in a natural manner, we have a highly occluded part of the container in different parts. And also for the robotic part is very challenging, this part, because the grasping areas that are available are reduced. So everything becomes a little bit more complicated and also interesting. So to summarize what the benchmark is using, we have 4 cups. Also, we have 2 filling levels. One is the cups being empty, and the other one is fill 90% of the capacity of the cup made by rice. We have also the 3 human grasp types. We have the 3 handover locations, and we are performing experiments with 4 different humans to reduce some human bias. And in total, this is making a total of 288 unique configurations. As another important part of the benchmark that we propose are the evaluation scores. So we divide the scores in a way, and we design the score in a way that they are interpretable. And by this, we mean that we would like to understand the scores. We would like the scores to tell us where the system is performing well, if it's in the vision part or if it's in the robotic part, or also where we have more room for improvement. So we would like to have this interpretability of the scores. And for doing that, we propose 3 types of measures. The one is evaluating how the vision algorithm is working. For doing that, we have different scores that are looking at how the object dimensions are being estimated, if there's an error there or if it's accurate. Also, we believe that the fullness, which is the filling level up to which the container is filled, is also an important information that the system should assess, because it's not the same handing over an object that is completely full, and we need to be probably more careful to not spill content than one that is empty. And also the object mass, because this is an important information for the robotic system to employ more force or less. A second part of the scores that we are proposing are meant to evaluate the robotic part of the human handover problem. So here we are evaluating the human hand prediction, also the end effector pose that Julia in a previous presentation made some emphasis on this part, like there is a mismatch between the calibration of vision and the calibration of robotics. So here we are aiming to evaluate that part, how accurate is the end effector pose, and also the object mass estimation again. And also we have some more global evaluation that also were discussed during this session, where here we're evaluating the delivery location accuracy. So how accurate is the robot in being able to deliver the container to the initial position where it was located. This is measuring different parts of the system that are relevant. And also we are evaluating the spilled filling. So we would like to minimize the amount of filling that is spilled. And also we are accounting by the human handover time, that in this case, we would like to minimize the time that is required for doing a successful handover. So for doing some final remarks from my side, we propose a benchmark for dynamic human to robot handovers evaluation that includes some interpretable evaluation scores. We deliver, and we already published a vision and robotic baseline that is working in 2 baselines. So we have it working on the KUKA robot and also in the UR5 robot arm. And this is already available. You can find it through the QR code or the link. And also we have an online challenge. So if you are interested in this part, just head to the link and you can enter to the competition and compare with other methods that are already working, which might be very interesting and relieve a lot of workload on your side, because that was already done in this case for the benchmark and also for other submissions. And I would like just to do a sneak peek as last part. We are also delivering in the next time a simulator. So in this simulator, we will have the UR5 and we'll have the streams of video. And in this case, what we would like to have a big emphasis here, because we would like to make possible for computer vision people that, for example, doesn't have a robot, or maybe laboratories that cannot afford a robot. If they have this simulator and they have expertise in computer vision, they can also participate on the benchmark. So this way will be a starting point towards that direction. And this is all from my side. So thank you for listening, and I will be waiting for your questions. Thank you.